Cloudlet. The Cloudlet structure is typically accessed through Wi-Fi connections. And inside we have virtual machines, which are the main features of cloud computing technology. What is done here is shown in this example, in which we have a cloud server, which is a local server, and a modem device together, which may be separate devices interconnected, or they may be on one device, one unit together. They join the network as a local cloud support system. However, of course, they do not have the full capacity and storage memory that the main cloud would have, so we call them cloudlets. And inside, they can support virtual machines to various devices that are local that request it. The cloudlet definition is based on mobility-enhanced small-scale cloud data center techniques. They are located at the edge of the internet nearby the mobile devices. And in some cases, some mobile devices could be programmed to be cloudlets. Cloudlets support resource-intensive and interactive mobile applications and provide powerful computing resources to mobile devices with low latency. These cloudlets are used between the UE and cloud device, somewhere in the middle. And a cloudlet is a data center in a box type concept that brings the cloud closer to the UE. So this is really like a cloud. Although it does not have all the features and capacity that a cloud will have, it is like a miniature device that has additional communication techniques, wireless and wired, brought closer to the device such that it is effectively used. Cloudlets use virtual machine to provision resources for UEs in real time over Wi-Fi networks. So therefore, direct one-hop cloud access is enabled, and that is why latency becomes so small and they become much more reliable. The architecture is based on 3 layers, and the cloudlet has a cloudlet layer, which is a group of co-located nodes, and it's managed by a cloudlet agent. Then there's a node layer, where multiple execution environments running on top of the operating system is what enables this, and this is managed by a node agent. Once again, on top was a cloudlet agent, on here is a node agent. Then there's the component layer. This includes a set of services that interface to the higher layers, as in terms of their execution environment, which is right here. Then, comparing these 3, fog computing, mobile edge computing, MEC, and cloudlet computing, in terms of mobile device-wise, well, fog computing, routers, switches, access points, and gateways, whereas mobile edge computing are servers running in the base station, mobile communication base station, something like an E node B or a G node B in the near future. Data center in a box concept is what a cloudlet is. The node location is, in fog computing, it varies between end devices and the cloud. Whereas in MEC, the radio network controller, as well as the base stations, are where the MEC needs to be located. When you look at cloudlets, these are local or outdoor installations. Software architecture are based on the fog abstraction layer in fog computing, the mobile orchestrator in the mobile communication network is what controls the MEC. And in cloudlets, it is the cloudlet agent. And of course, there's the node agent as well, assisting the cloudlet agent. In terms of context awareness, fog computing is medium. However, mobile edge computing is high. And relatively, cloudlet computing is low, as the necessary virtual machines that are going to be distributed are already prepared and delivered first in advance. Proximity is based on the structure of the network, where fog computing can be one or multiple hops. When it comes to MEC, you're talking about one hop. This is because your smartphone is one hop away from the base station, and the MEC is located right next to the base station. That is why one hop. Although this one hop is a little bit of a longer one hop compared to the cloudlet one hop, because these one hops are wireless local area network based Normally they are wireless LAN, Wi-Fi based. So therefore, cloudlets are typically supposed to be closer compared to where the macro base station is in your mobile communication network. Then comes access mechanisms. When you go to fog computing, it is Bluetooth, Wi-Fi, or it could be the mobile network and other wireless personal area network techniques, such as Zigbee. When it comes to MEC, it is the mobile network primarily. However, you could use Wi-Fi techniques. When you're looking into cloudlet, Wi-Fi is the primary access type. However, other components could be used to connect. The inter-mode communication here in fog computing is supported. In mobile edge computing, it's partial, and also cloudlet computing, it is partial as well. Looking at these categories in their characteristics. The physical proximity, for fog computing and cloudlet, it is high. For MEC, it is relatively low. When looking at the power consumed, mobile edge computing consumes more power because you need to send your signal to the base station. And that is why the physical proximity being low results in a higher power consumption. When it comes to fog computing or cloudlet computing, you're talking about a device that most likely is very, very close, and therefore the power consumption is low. Computation time. Well, fog computing here will take higher, longer periods, whereas mobile edge computing and cloudlet computing are expected to be faster. Context awareness. Mobile edge computing has more knowledge, more prediction, more fetching of relevant contents, so therefore it is going to be more sensible to what is going to be communicated. That means that the overall context awareness is high, whereas fog computing and cloudlet computing are relatively lower. The logical proximity is in ways such that cloudlet computing is ensured, whereas fog computing and MEC are maybe. Then we have non-IP support. This is also important because not all techniques and devices use IP-based protocols. Looking into fog computing, it is a yes, whereas mobile edge computing and cloudlet computing, it is a no. However, mobile edge computing and cloudlet computing can be designed in special ways such that they can support non-IP devices and non-IP services. These are the references that I use, and I recommend them to you. Thank you.